How's it going, everybody? It's your boy, Homie G, and I'm back. All right, my little homies, I got a great lesson for you today on multiplication. Let's review before we go back to school. And for some of you, this might be brand new, especially for the little homies, because I'm going to start actually with elementary age little homies, and then we're going to go into middle school, and then some high school. And again, the topic is about multiplication. So first, I learned multiplication the old-fashioned way, because Homie G, he ain't young as he used to be. Now, a lot of people, like your parents, or maybe even your grandparents, we learn multiplication doing memorization. So multiplication tables. Maybe you're still learning that in school. I don't know how math teachers are doing it today, how they're teaching multiplication, because I'm a science teacher. But anyway, I'm already having my daughter learn multiplications memory by basically looking at the tables, and I explained what this is to her. And then it dawned on me, there is a lot more to multiplication, isn't there, my little homies? Yes, there is. So let's go ahead and look at the multiplication table. So I got the 2's up here, and I got the 3's up here, just for an example. Now, so we can see the answers. A lot of kids are going to just memorize 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, and they're going to see the pattern of every time these answers increase by 2. Right here, the answers increase by 3. Okay, so there is a pattern. There's a lot of pattern to multiplication. By the way, multiplication, little homies, is just a faster way of adding. So instead of using our fingers and adding on paper, multiplication allows us to add much more quickly. Okay, so I also taught my daughter that these here represent shapes. Yes, kids learn shapes. So 2 classic shapes kids learn: squares, rectangles. Now they have to understand the difference. When you teach multiplication to your kids, parents, explain to them this way. For example, I have up here a 2 by 3. Now combined, the whole thing around is a rectangle. So our multiplication 2 times 3 produces 6 is an actual rectangle, as you can see, of 1, 2, 3, 4, 5, 6 boxes. Let's just call them boxes inside of this rectangle. You see that? Okay, so 2 times 3 gives us 6. So instead of going 1 plus 1 plus 1 plus 1 plus 1 plus 1, I could simply count these 2, 1, 2 on my left, and the top 3. And then with multiplication, I understand that means 2 times 3 gives us 6 total boxes. So I don't have to count with my fingers. I don't have to add. Simply multiply. Okay, now, this is a good question here. So, can you spot in these 2 times tables, the 2's and the 3's, my little homies, where we don't have a rectangle? There's only one in each. Where do we have a square? Okay, go ahead and pause the video, parents, if you want, and I'll give you the answers in now. So, if you notice, here we have a 2 by 2, and here we have a 3 by 3. These produce not rectangles, but squares. So if I draw it again, and my drawing isn't that great, but I have 2 and 2, this is going to be a square, not a rectangle. All the other ones, all of these, and we keep going, will produce rectangular shapes when we draw them, like boxes, like so. Okay? So, there you have it. Every times table where the number is the same when you're multiplying them together, that's going to make a square shape versus the rest. when you draw it out, it's going to make a rectangle. All right, my little homies. That's been your elementary lesson. Now, let's go on and see how this applies to middle school. So, let's say you happen to be working later in life at a store, and there's a whole bunch of boxes on a table, like so. Homie G's drawings are the best, aren't they? Anyway, this is a simple one. Let's say your boss asks you, hey, can you count how many boxes are on top of that table? And they're placed like so. So you have a 4x4. So instead of going 1, 2, 3, 4, 5 and counting them all up, you can go 4 times 4, so long as it's just one layer, so to speak, one layer of boxes. We have 16. 16 total boxes on top of that table. And again, this comes back to my times tables. 4 times 4 is 16. And yes, it would be a square because it's the same number. Now, my drawing, not so great. But it's the same number that we're multiplying, so it would be a square. In real life, it would look like a square, a perfect square, okay? Now, these are boxes, of course. So we're going to get into shapes, and we're still talking about shapes. Now, what if we had an additional dimension? Now you're at Costco, and your boss tells you, hey, go measure go take inventory, I should say, of how many boxes are on that pallet up there. And you have to go to the aisle, and you have to go to the pallet. And now here we go. We got 3 by 5 for the first top layer. But instead of trying to figure out how many are around and try to go behind and all that, you could simply get your third dimension, the way down, I would explain it as here, okay, or your height. And now we have 3 times 5 gives us 15, times 4, so there's a total of 60 boxes there. And you wouldn't waste time counting them all up if you just understood that this is simply multiplying the top 2, first layer, times the bottom, times going down, how deep it is. And that gives us a total of 60 boxes. And what does this create? Well, it creates a rectangular prism, another type of shape you might have learned about in elementary, versus a cube, also 3 dimensions. We have length times width times height. A cube is a special type of rectangular prism, okay? And again, all this goes back to you learning multiplications the right way, not just memorizing, but understanding what it is that you're actually creating in your mind, or drawing when you have to draw it in elementary to explain. Let's look at one other one that I forgot for the elementary kids. Why is 2 times 0, 0? And why is 3 times 0, 0? Okay, well, can you draw it? Can you draw, if you're going to draw 2 squares by 0 the other way? Well, that means nothing. You can't draw that. You can't draw it because it's by 0, going that way, not going down when you draw it. So technically, it's 0. Okay? So that's a simple explanation. I'm sure there's a more mathematical reason why. Again, so you could always talk to your math teachers about that. All right, now we're going to move on to the high school connection. Okay? This way. So, when you get to high school, my little homies, or if you're in high school, you're going to learn algebra. The first thing you're going to learn how to do in algebra is how to graph lines. And you're going to be given this equation, y equals mx plus b, the slope-intercept form. It's a classic equation, and that's going to show you how to draw all sorts of lines. Lines going up, lines coming down, straight, whatever, in the first quadrant, which is the right here. Now, but then you're going to get to Algebra 2. And in Algebra 2, you're going to be taught about parabolas or quadratics. And yes, it still relates to your elementary level math in a way. Okay? So let's look how. So now look at my times tables here. 1 times 1, 2 times 2, 3 times 3. All of these are these squares that we were drawing back in elementary. Box 1 times 1. 2 boxes by 2 boxes. 3 boxes by 3 boxes. These are our square functions or graphs. And they look like this. And when you graph it, it's going to make a perfect parabolic shape this way and that way if you get into the negative numbers as well. Okay? 1 squared, 1. 2 squared, 4. 3 squared, 9, etc., all the way. It keeps going. Keeps going. 7, 8 squared. And there you have it, my little homies. That's how we connect multiplication with some real life application. And then when you get into the more abstract math, quadratics, right? Okay, so this has been a lesson for you right before the start of the school year. I hope it's helped you out, and I'm out. Peace.